TurboDesign Volute, just like in TurboDesign 1, we start by loading the input file that was exported from TD-Pre, and then we can see the machine type has automatically changed to hydraulic turbine. And if we proceed to the main dimensions, then these have already been pre-filled from the TD-Pre file. And also the cross-section type has been set to symmetric, and the shapes at the entry duct and inlet all have been set as circle because this was specified in TD-Pre. And then the inlet tube settings are also preset to match those in TD-Pre. And here we have the option to choose the type of inlet, such as tangential or radial. And in this case, we can go with a tangential inlet. And then finally, the most important part is the outlet boundary conditions, which is the specification of the radial and tangential velocity components coming out from the volute exit into the stay vane. So we can specify a constant value throughout the circumference, or we can specify a profile as well. And in this case, we can go with a constant value that has been specified from the TD-Pre report, both for the radial as well as the tangential velocity components. So next we can run the calculation, which is very quick, runs in a couple of seconds or so, and it basically runs a 2D inverse design code to give us the optimum area distribution for the given volute outlet velocity profile. And then finally, in the post tab, we first have like a 3D view of the volute that we generated. And then we also have some plots, such as the cross-section area variation along the circumference. And then finally, there are also some useful performance parameters of interest, as the total head loss estimate, and then other geometry parameters as well. And once we have the volute design, it's then possible to directly export a solid IGES model of the same for CFD analysis with the runner and the other components.